In this video, we will talk about the chi-square test of independence. Emphasis on chi. This is, imagine that you're saying chi. Not chai, it's chi. People usually say chai or chi. It's not that, it's chi. Okay, like the Greek letter chi. Okay, so this is the chi-square test of independence. So I will say that about basically every group is going to be using this test. So this test is probably going to be the one that many of you guys are going to use, okay? Because you guys are going to have a categorical variable that you are relating with another categorical variable. And for many of you guys, you have many levels. So you have many options, okay? Maybe not just gender, okay? So notice here we have major, which can be many different levels. You can have arts, business, whatever, and you maybe have gender, and here gender can be male, female, other, whatever, okay? So the chi-square of independence, you do have to be very careful with because you need to check that they're independent from one another, okay? And your expected count is greater than 5. And I'll show you guys what that looks like. Now, in terms of the null and the alternative, actually, these guys are really easy because there is no numbers that you can kind of try to do with categorical variables, at least with independence. Okay, so the way that you would write it is variable A and variable B are independent. Whatever your variable A and variable B is, do not write variable A or variable B. Write down what your variables are. So you can say major and gender are independent. And then your HA would be variable A and variable B are not independent. And if they're not independent, that basically means that they depend on each other. That means that they're associated, okay? So one thing that you want to say is whenever you talk about two categorical variables, do not say correlation. You will get docked points if you say correlation. So two categorical variables cannot be correlated. They can only be associated. So what you want to say is association. So when you go ahead and write we rejected the null, we can say that both variable A and variable B are correlated. No, don't say correlated. You can say that they're associated. That's what you want to say. Okay, so that's basically how you write the null and alternative. So you don't have to worry about writing letters. You just have to write these sentences. Now you do have to check these two different assumptions: independence and expected count is greater than 5, and I'll show you how that looks like. So let's go to our data. So we know that we have two categorical variables and they have many different levels, and we want to use the chi-square test of independence. So let's say in this case, I don't know, what do we want to check? Let's look for major. And let's say we want to know, I don't know. Well, let's just do major and female and male. Let's just do these two. Okay, so let's say we want to do gender and major. So we want to know whether these two are associated with one another, or maybe they're not. Okay, so what I'm going to do in my, I'm going to write my null and alternative. So you're going to say, let me do a different color. Your HO is going to be that gender and major are independent, which means that they have nothing to do with each other. So basically, whether males or females, doesn't matter what your gender is, or other, or trans, or anything, doesn't matter what you identify as, your major isn't going to be, they're completely not associated with each other. And then HA will say that gender and major are not independent, which basically means that they are dependent. that they have something in common. Maybe more males tend to be business majors. Maybe more females tend to be, I don't know, math majors. I'm not sure. So there's one group that tends to be more into one major than the other. Okay. And actually, one thing that you might want to look at is look at your graphs to see if there actually is an association. So usually when you're doing all of these tests, you want to be able to do a graph using these two variables and then seeing if there's any common trend and then talk about your tests. Okay, so now how are we going to do that? Well, first we have to think about independence. Okay, do the assumptions check. So in terms of independence, remember, I'm not quite sure because I know that many of you guys are either together or you guys are siblings or you guys are cousins and you guys were my people who actually answered my survey. So the independence, I'm not sure if you guys are independent because if I'm thinking that maybe you guys are in the same family, maybe there might be like same majors among your family. I'm not sure. So maybe they're not as independent. And then expected count. Okay, so this you can easily get from testing it. So what you got to make sure is that you click on a correct button. So I'm going to show you what that is. So let's go to our data and we're going to look at gender and major. And actually, we already know how to test this. We've done this before. So you're going to go to stat, click on tables, then click contingency with data. Now the row variable and the column variable don't matter. So I'm going to pick gender here and I'm going to pick major here. Okay, gender and major. You're not going to group by anything. And now what you're going to do on display, you're going to click on expected count. You're going to click on that. All right. Then here, make sure that you click on chi-square test of independence, which is always going to be clicked. Okay. And then you're just going to go and click on compute. Okay. So now here, we have our row and our column. We have our contingency table, which you've seen before. And then we have our p-value, which is right here, really, really low. Now you're going to get a warning sign whenever you have an expected count less than 5. So if you see here, you can see that in arts and music, the thing in parentheses tells you how many were expected to, how many people were you expected to have in these cells. The way that they got this number in parentheses was basically multiplying the number of females times the number of art majors and then dividing it by 103. That's how they were getting the expected number. So they did that all for you. So some of them were good. They were satisfied. They were greater than 5, but there was others that weren't. So because that assumption was not satisfied, so if you go back to, or where did it go? If you go back to greater than 5, this one was not satisfied. And typically we would use a different type of tests. So so yeah, that sucks. But you're gonna continue anyways. You're gonna go ahead and do the tests, but you do want to make these claims that these assumptions were not satisfied. Okay, so in this case, we can see that our p-value is low, so we're gonna reject HO. So we can say that there is a dependence between gender and major. Okay, so but keep in mind that a lot of our test assumptions were not satisfied. Okay, so that's basically what you're doing. The assumptions are not very difficult to kind of test as compared to a numerical one, but that's basically what you want to be able to do with the chi-square tests of independence.